Okay, so for we're going to look at example 8 here. And what it wants us to do is it wants to investigate the one-sided limits graphically. So investigate one-sided limits graphically. And so they give us a bunch of different options. We want the limit as x approaches 2 with the plus or minus, and then we want 1 over x minus 2. When you guys see a plus minus after your limit like this, this means to investigate the one-sided limit separately. So this basically means figure out what's going on at the right limit, figure out what's going on at the left limit. So part B wants us to figure out what's going on the limit as x approaches 0 from the left and from the right of 1 over x squared. And part C wants us to figure out what's going on limit as x approaches 0 with a plus, so from the right-hand side only, of natural log of x. So if we think back, when you subtract 2 like this, this takes your base function of 1 over x and it shifts it to the right 2 units. So that is going to create, if we go over to the right 2 units, that's going to say that the vertical asymptote is there. Since we're supposed to do these graphically, I'm just going through and graphing this from like Algebra 2 stuff. So this x minus 2 said go to the right 2 and then fill in the rest of the graph like you would from your transformation stuff. So our graph will look something like this. Now we're supposed to be considering these limits separately. So we want to know what's the limit as x approaches 2, let's say from the left of 1 over x minus 2. And then we want to know what's the limit as x approaches 2 from the right of 1 over x minus 2. Well, as you approach 1 over x minus 2 from the left, if we're approaching, here's x equals 2. If we're approaching this from the left, we're approaching it kind of here. And our function is running off down towards negative infinity. So we're going to say that that equals negative infinity. Now, negative infinity technically is not a limit, but we use the symbol to kind of describe what's happening. And the reason it's not a limit is that negative infinity is not a number, so it's not technically a limit. The limit technically doesn't exist, but rather than just putting does not exist, we can capture a little bit of extra information and saying, well, it doesn't exist, but it's not a true limit, but we can still give some description of what's going on. So as we approach it from the right, on the right-hand side, I get close to 2 from the right. I look and say, what are my y values doing? Well, on the right, my y values are running up this vertical asymptote, so they are heading off towards positive infinity. So we investigated part A graphically. Part B, 1 over x squared, its graph looks like this. It's kind of both sides curve upwards. There's a vertical asymptote at 0. And we're asked to figure out what's going on with part B. What's going on there? So we say, all right, well, the limit as x approaches 0 from the left of 1 over x squared. Well, as we approach 0 from the left, x equals 0 is the y-axis. So as the x's get closer here, we say, what are the y's doing? The y's are running upwards. And so we get that's going to go off to positive infinity. Then we say, well, what's going on with limit as x approaches 0 from the right of 1 over x squared? Well, as we get closer to 0 from the right, the y's are running upwards again, so we would say that this one is also positive infinity. So we got a vertical asymptote there. the pictures that we got, we could say, well, you could write this as limit as x approaches 0 of 1 over x squared. We could say that that is now infinity. Even though it's not a true limit, you could write it this way and it would be understood that it's approaching infinity from both the left and the right. This one, part A, so we had the left was going to negative infinity, the right was going to positive infinity. So we can't really combine them together into a single statement because they're approaching different types of infinity. But this one where they're running off to the same infinity, we could view it that way. But it is good to keep in mind that in infinities, technically they are not a true limit. This just kind of describes what's going on there. It's giving us a description as to what's happening. But since it's not a number, it's not a true limit. So let's see here. What do we got left here? Natural log of x. Natural log's graph looks kind of like something like that. We're supposed to say what's going on as we approach from the right. So limit as x approaches 0 from the right of natural log of x. And from the graph, this is pretty easy. If we're approaching 0 from the right, that is the vertical asymptote, and our function is running downwards along the vertical asymptote. So this would be negative infinity. As you approach from the right, the function is heading down towards negative infinity. And that's basically what's going on here. Whenever you have vertical asymptotes and you have these functions running up alongside a vertical asymptote, you'll start seeing these infinite limits of things either growing up towards positive infinity or heading down towards negative infinity, and that's something you'll see frequently around vertical asymptotes. So we'll stop that example there.